So today we are going to be overclock testing this NerdQaxe++, and as you can see we just plugged it in. Currently we don't have a mounting for it, so we just got it stuck on the table and then a little bit of airflow underneath. We're still working on a build for the BitAxes, which I'll show you quickly right now. So it's kind of this board build, and we're going to make a similar one for the NerdQaxe. We were going to add it on, but we're still looking for a mounting solution. So currently we're just mining it on the table at the moment, which is not the best, but we will find that very soon, maybe in a couple of days. Just get it all finished and then work on one for the NerdQaxe. So one thing that I have noticed, and we did kind of go over it in the last video, as you can see here, it does slowly ramp up. So there's going to be some estimation from my part on how much we can actually get out of this. I'm assuming because it's 4 gamma chips, it's going to give us kind of whatever we can overclock the gamma to. So maybe 1.5, 1.6, and then times that by 4. So I'd say we're looking at around 6 to 7 terahash is probably going to be the highest that we can ever go without basically running out the power supply, because that is the main bottleneck that we'll be working with today. The power supply currently goes up to 120 watts, and I know that if you added all the gamma chips together, that's going to come to, let's say it's 30 watts per chip. That would bring it out to basically 120, but you want that 80-20 rule to make sure that you don't burn out the power supply basically. So we have about, up to 100 watts maybe. That's how far we can take this, and I'm estimating 7 terahash, 8 terahash maybe before the power supply basically clocks out, and I don't want to push it any further than that. We have seen other power supplies on Amazon that we can use, obviously the Meanwell ones, but this is a 12 volt system, so we can't run it on the same as the BitAxe system. But yeah, we're just going to be trying to actually set up the script that we have for the BitAxe overclocking. We're going to try and do that. If that doesn't work, then we're just going to have to manually up it as we would test it out, like that. Like everyone started off originally doing that. So you can see we're at about 1.2 terahash there. Best difficulty is 5.76 million. And you can see RPM, temperatures, 48 degrees. So I'm assuming we can let it run to about 55, something like that, 60 degrees maybe. These voltage regulators, I don't know if the temperature on them is recorded, as in are they all put together and then averaged out. We'll have to find out. But yeah, let's get it actually up onto the computer. Let's test it out. Also, we have a video coming where we're going to be changing the heatsink, possibly. I know there's a copper one that you can get, but I don't actually know if this is aluminium or copper, or it's copper just put into a different color. Does that make sense? Like these tubes that are running there, are they actually copper, but they're, I don't know the word for it, anodized or whatever, to be silver. But there is a copper version of this with a copper fan. So this is a Thermalite or Thermalite. I don't really know how to pronounce it. And you can get a copper version, so maybe we'll be doing a replacement on that as well. But now let's take it over to the computer and start overclocking this thing. So right around 2 terahash right now, so we've got to let it warm up to about 4 to 5 terahash before we can start overclocking. So here we are on the home screen, or whatever, the Axe OS, or NerdQaxe OS, I think that's what it's called. And we are going to be doing the same thing, hopefully, that the BitAxe script can work with, because I'm assuming it's just going based off the same thing in terms of the frequency and the voltage and the temperature stoppage. But they do have a nice system settings in here, which I don't know why they don't have it for the BitAxe, but it has a temperature shutdown right here. So maybe that's coming in a later release, I'm not too sure. But we've got the temperature shutdown at 65, so we've saved that already. And I think we're just going to try it out just right off the bat. If we go to dashboard here, you can see that it's expected even without overclocking. So this is on the frequency is default and the core voltage is default. So remember, we're going for gamma chips, so I'm assuming that it just increases all of them at the same time. And if we go to the dashboard here, it gives us an expected 4.8 terahash, so nearly 5 terahash. And as I said, estimating maybe 7 to 8 terahash when the overclocking starts kicking in. That's obviously if the heatsink can keep up as well, and if the power supply can actually keep up. So as I said, we're going to be doing the same thing. So we got that command window open right there. We're going to copy this and we're going to paste it in here and click enter. And then we're going to copy and paste that and click onto here to give us the IP address. So this is the reason that I think it would still work, is because you're entering in the IP address and it's solely going to go based off of that. But we also need to edit some things actually before we get in there. So let's try find the file first. So in here, we'd actually need to edit a couple of things, I believe. I don't think it's going to have any effect in terms of, selecting what IP you're going off, because it is only 4 chips, but they're all controlled at the same kind of parameters. I don't think it would matter too much. The max or the minimum input voltage, what do we want to start on is the question. I think we still want to keep the max temperature, but the max power, we're going to go with 100 maybe. That's going to be because of the plug that we're using, so I don't know if it's changing because of this. And then I think if you set a default core voltage, so default voltage is going to be 1150. We're currently sitting at the default of 500, so we can actually input 500 to start off with, or we can input 600 to start off with, sorry, because that's what it's already running at. And I think that was it that we needed to change. There's nothing else that I really want to change here, just because the frequencies are going to be the same, and so is the input voltage. So we're only really getting rid of the max power so it doesn't shut down instantly. So we're going to save that and we're going to exit out of that, and then we need to actually input the IP address. And then from here we can actually set a core voltage. So if you look down here, you can set an initial core voltage and a frequency. So because our ones are sitting at 600 already as the default, we're going to go with 600 on there. So just dash V and then space 1150 and then dash F and a space, and we're going to put 600. So I don't know if this is actually going to work. This is the first time I'm trying this out, so you get to try it out with me, and I'm assuming it is going to work, but if not, we'll just do it the old school way. And you guys can let me know in the comments if there is any different benchmarking for the NerdQaxe. So let's click enter there. So we've clicked entered. It looks like it is running up. I mean, it's just going to apply the default settings, so that's kind of expected from what we're seeing right now. But as soon as it goes past those default settings, we'll need to check in the settings if it has actually changed over to, 625 on the frequency, or if the power is going up. Or we also need to keep an eye on the input voltage. So I didn't really set a lower input voltage that it would hit and then it would actually cancel out. Because we're sitting at 11.3 currently, it should be a 12 volt system, so we kind of need a little bit more volts to run the system. But I think that's to do with the actual plug that I bought. So the plug that I bought is not rated for this 12 volt system as much. So it does say right there that you have a frequency input voltage is above the maximum allowed voltage of 550 MV stopping current benchmark. So what that tells me is we actually need to allow, obviously, the input voltage of 12 instead of 5, so we didn't even think of that. But let's go in and change that, and then we'll get it running again. So we're in here, and we need to have a maximum input voltage. This is the one that we forgot to check for. So it's going to be, 12,000 is going to be the maximum, because we're not even at 12,000 right now. And then we want to set one for the minimum input. I believe the way that you do it is you take 20% of whatever the maximum is. So if we're sitting at 12,000, 20% is going to be 2,400. So the minimum input maybe is 10,500 volts. I'm going to just be safe and go 10,750. And then that should hopefully stop it as well. So let's save that and then let's run it up again. So there we go. We've got it set up again. Let's just click enter. and it's not going to do any changes on this dashboard, but we'll be able to see. Let's zoom it in a little bit here. Let's take it out to there. And what does it say now? Failed to resolve API error. So currently I do not know how to fix that, and I am gonna just say that maybe it's not working for this currently. I've just found out the reason. There's no actual IP address input there, so we'll need to go in and do that again. So we're in here and we just need to take this. So I was a little bit confused then because obviously we got it running straight away and then it said the error, but let's just hit enter on that and let's see if it starts running, and we can kind of monitor it from there. So currently it's just going to run at the current settings that we're seeing here. So these are the default that we input, and then it's going to start climbing up from there. I'm probably expecting to see maybe an extra 100 gigahash every time we up the frequency a little bit. So with the gammas that we are overclocking on their own, single chips, maybe the top that we get up to is 1170 on the voltage, and then the frequency is normally something like 725, and that achieves a hash rate of around 1.6. So I don't know how it works with, obviously 4 chips, there's going to be a lot more heat, there needs to be more, cooling down, and we haven't actually got the best cooling solution currently, just because it's on desk and there's not really much cooling going on there. So it's still giving us this input voltage is above maximum allowed value of 5500, but I'm pretty sure we just saved it. But I'm going to work around it and try test it out. Let's see if we can actually get it to run, and then we'll come back if we got it to run, and if not, I'll give you kind of the results of us overclocking it default levels. So before we get into the results, I just want to let you guys know that you can get 10% off if you use the code Sterling in the first link in the description as well for these NerdQaxe pluses, and I believe that they ship all across the world. Currently the April batch is sold out, but they do have a May batch coming soon and is available for pre-order. I think a lot of you used the code for the April batch, so it should be coming to you very, very quickly. If you just add it to cart here, and then I believe you check out, it will get you 10% off. And this code can also be used if you go back as well. It can be used to buy a BitAxe Gamma if you want to use that as well. So you get 10% off that as well. So when it comes to the results, as you can see here, we did have a little bit of problems. We did get it fixed. So that's the main thing about the results, is we did get it to work for here. All we needed to do was run this as an administrator and it seemed to work. So we can go through actually all the results here and let's get it up to the top. So we started at 150,500. As you can see there, we have the core voltage and then frequency, then the hash rate, input voltage, temperature, and then the VR temperature. Obviously, I don't know what the temperature is exactly because it's split against 4 ASIC chips, but I'm assuming that it's the average of the 4, same with the VR temperature. So we got all the way up to 1150 and then 675, but it actually cut out, and the reason for this is that the temperature did shut down at around 65 degrees on the VR. So I believe that this shutdown temperature is based on the VR temperature and not the chip temperature. That's at least what I'm assuming. Because if you look down here, it says applying new settings and then starting benchmark. And then it says input voltage is above the maximum allowed value, stopping current benchmarks. And then it says reached thermal or stability limits. Now, this is not actually showing up in these kind of logs that we're seeing here. But when we were looking at the screen for the NerdQaxe, it was actually saying or given an error of temperature limit actually passed. So I'm assuming it was right here when it passed that temperature limit. So it's not going based off of the script, it's going based off of what this says down here. So this 75, which was actually at 65, and that's when the VR temperature crossed that threshold. So what we need to do is we need to actually up that and then run this again. And we're probably going to run it to about 720 0.25, and hopefully we can get something out of it and we can get better results than this. But let's start it off at 650 and then we'll go from there all the way up to probably 750 and see what the overclocks are giving us there in terms of the hash rate and the efficiency. So after letting it run for a while, we do have our results here. So it did actually stop on its own, and this was because the reached thermal stability limits. Oh no, if we scroll down here, I'll show you what it is. That was the previous one. If we see here, the power consumption exceeded our 100 watts limit. So we didn't want to go over that just because the power supply is only up to 120 and we're trying to keep it within the 80-20 rule. So making sure that that doesn't go above it. But it stopped at a core voltage of 1170 and a frequency of 725. So that's kind of what we'd get out of a gamma with standard overclocking and doing this hash rate testing with a hash rate of around 6 gigahash. So that would be 1.5 terahash per chip, which is kind of on average what you'd see out of a gamma that's slightly overclocked as well. So our highest hash rate that we hit on average, so across the board, is 5881. One thing I do want to mention is the overclocks that set in take a little bit longer to kind of ramp up when you're doing this. As I said in the first video that we did, it takes a while for the miner to actually start up and spin up. So you kind of got to give it a longer time, I feel like, to get steadier overclocks. As I said, the average hash rate of our highest hash rate was 5.8 terahash, or let's round it up to 5.9 terahash there. And then the most efficient settings that we got is 16.7 joules per terahash. So I think these chips normally run at 14.5. That's the lowest that they go. So close, but not really that close from it. We did get a better result back up here for top efficiency. So we had 15.87 joules per terahash. So getting closer to kind of the normal range. There's a lot of things that we need to kind of fix, obviously being the power supply, but we also don't really want to overclock it too much in the settings here, because on the BitAxe is only one chip. But if you click here and you inspect element and you do the whole inspecting element thing, if we just take this out, so that didn't work. But anytime you go above whatever's on here, it does give you an error message, like a danger zone error message, but I can't really see it right here. It basically says that you shouldn't go above this frequency. Maybe if we click here, oh okay, so once you edit here, as you can see, the frequency goes into the red. Then if you click save, it's going to come up with this unsafe setting, so you void your warranty if you go above the normal overclocks that they set for default. So I don't know if you should be going over that. With the BitAxe, it's only one chip and it's less expensive than the NerdQaxe, so you kind of are able to push it a little bit more. But with this, you don't really want to push it too much. It is a way more expensive bit of hardware. But we will be coming with some upgrades that we're going to be doing. The main one that we're going to be doing is adding this Thermalite fan and heatsink. So currently there is a lower profile version of this on there, which I think is aluminium, but this one is copper and it's a little bit thicker. So you can kind of see it here. There's a lot more room between the fan and the bottom there. And then we can kind of see what it looks like. So we're going to be taking off the one that we have now, replacing it with this one. It's the same fan size, it's going to be 12 volts, and it's slightly thicker, so heat dissipation should be a little bit better. Another thing that we need to do is add some heat sinks to the voltage regulator, just because those were creeping up as well. So 68 degrees at 50 degrees. You know, that's not really massively too much. The voltage regulator on the regular BitAxes or the BitAxe Gamma gets a lot hotter at these frequencies, but I think that's because it's on the back of the chip. But overall, kind of like the highest hash rate that we hit up to is 6 gigahash. I definitely know we could push it further if we have a better power supply. I don't really think cooling is taking too much of effect right now, but when we get into those higher wattages, that's when
you are going to need a bigger power supply to start overclocking it more. And then maybe in the future we'll get one of those power supplies and really push this to the limit. But currently I just want to stick it on the rig, just let it run for a little bit, and then, you know, see kind of what difficulties we get in after a week. And then there'll maybe be a video of us putting this on, so making this upgrade, and we'll see where we go from there. So as I said, there's a link in the description for if you want to get one of these, and make sure you use the code. Let me know your thoughts on overclocking one of these, and make sure you like the video and subscribe for more content like this.